Alright, so this video we're going to be talking about section 6.2, and it is on the law of cosines. We talked about in 6.1 the law of sines. Now we're going to talk about the law of cosines. Now, we now look at another relationship that exists among the sides and angles in an oblique triangle. Once again, we're dealing with a non-right triangle. If you have a right triangle, you deal with the basic trig expressions of SOHCAHTOA and all that stuff. But if you have a triangle that's not a right triangle, then that means you need to use one of the other things, because those original trig equations or the trig relationships don't work. The law of cosines is used to solve triangles in which two sides and the included angle are known, or those in which three sides are known. So that's what we're dealing with here. Very specific applications for these two laws. Remember, with the law of sines, you were able to use it for two sides and or two angles and the included side, or two angles and a side, or that special case that you actually had to check to see whether or not you had one or two triangles, if any triangles, and that was the side-side angle. The law of cosines will deal with the side angle side and the side-side-side that hopefully you're familiar with and remember from geometry when you were proving triangles congruent. Now, the law of cosines says if A, B, and C are the measures of the angles of a triangle, and A, B, and C, lowercase, are the lengths of the sides opposite these angles, then the relationships that follow, A squared equals B squared plus C squared minus 2BC cosine A, B squared equals A squared plus C squared minus 2AC cosine B. I'm not going to read the last one. You guys can read that. But what it says is this. It says the square of a side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of the included angle. Now, what I want you to see here is this. A here, A here. Everywhere else on this side, B's and C's. B here, angle B here. Everywhere else on this side, A's and C's only. So whatever letter you have here is the same letter you're going to have in the cosine expression at the end of the right side. Everything else is going to be set up exactly the same. A squared plus B squared minus 2 times A times B times cosine C. Now, you're going to recognize, hopefully, or it might kick off in your brain just a little bit, that, hey, this kind of looks like the Pythagorean theorem. Well, it does, but it's adapted. It's adapted for the fact that we don't have that right triangle. And that's where this part over here comes in, these last terms coming in to adjust for the fact that we do not have a right triangle. Now, those equations you need to know, but hopefully with just that little trick of A here and A here, if you remember the setup of one, you can fix the rest of them and just change the letters. So don't really memorize the thing. Learn how it's set up. Now, if you're given two sides and an included angle of an oblique triangle, none of the three ratios of the law of sines is known. This means that we do not begin solving the triangle using the law of sines. Instead, we apply the law of cosines and the following procedure. The first thing we want to do is we want to use the law of cosines to find the side opposite the given angle. And then number two, we want to use the law of sines to find the angle opposite the shorter of the two given sides, because this angle is always acute. Now, let me explain something, and hopefully you'll understand this. Remember, the shorter side is always going to be opposite the smaller angle. When all three angles of a triangle will add up to give you 180, that means that at most you can only have one obtuse angle in the triangle. Guys, you need to understand, and we'll talk about this in the next unit that we talk about in trig when we get into unit circle trig. But I want you to just understand right now that the inverse sine function will not give you an obtuse angle ever. It's always going to give you an angle measure between -90 and +90. The law of sines is used only to find acute angles. If you go back and look at the 6-1 section, when we found the multiple part triangles, if there were two triangles, the first one that you found, that first angle that you found, was an angle that was always going to be acute. And then what did we do to find the other angle? We subtracted it from 180. We didn't use the law of sines to actually find that angle. We just subtracted it from 180. So the law of sines, the inverse sine function will not find you an obtuse angle. That's why you always want to do the angle opposite the shorter of the two sides given first, because it's going to find that angle to be acute, which the law of sines will find, and then just subtract to find the third angle. So let's do an example here. All right, so we've got side angle side here. And it says solve the triangle in this figure with A equals 60, bang, B equals 20, bang, and C equals 30, boom, right there. All right, so the first thing we want to do is we want to find A. And we know that A squared is going to equal B squared plus C squared minus 2BC cosine of angle A. So that means we're going to have B squared, which is 20 squared, which is 400, plus C squared, which is 30. When we square that, we're going to get 900, minus 2 times 20 times 30, that gives me 60, times the cosine of 60 degrees. And then when I calculate all that, A squared is going to be equal to, just a second, all right, that gives us 1,240. Now, keep in mind that that is A squared, that is not A. So we have to take the square root. And that gives me 35A is going to equal 35. We're doing sides to the nearest tenth and angles to the nearest degree, so 35.2. All right, now at that point, we know all three of the sides. And once we know all three of the sides, we can use the law of sines and go from there. So we know that 35.2 over sine of 60 is equal to 20 over the sine of B equals 30 over the sine of C. Now, what we want to do is we want to find the one that's opposite the shorter side. So we're going to find B. That means we're going to use this ratio right here. So when we do a cross multiplication, we're going to get that sine B is equal to, and I'm going to go ahead and break it down, but you know you're going to have 35.2 times sine B and then equals 20 times sine 60. So 20 times the sine of 60. Then I'm going to divide by the 35.2 because that would have been over here and divide, etc. All right, and that's going to give me approximately 20 sine 60 divided by 35.2. 0.49 21. Now, I'm stopping at 4 decimal places in what I write down, but I'm actually using all the decimal places when I do my inverse sine. And that gives me an angle B that is approximately 29.476 or 29 degrees. Now, here's the thing. Now I can use subtraction, and I know that C is going to equal 180 minus the sum of the two angles that I know here, 60 plus 29. That's going to give me 89. When I subtract that from 180, I'm going to end up with 91, which is an obtuse angle. So that's this angle up here is 91 degrees. So then, of course, I'm going to list out everything I found when I claim that I've solved the triangle. All right, so that's me solving the triangle. Now, I want to show you something. I'm going to erase this and come back to it, but we're going to keep this 35.2. And let's say that I did not do this. And I'm going to write this in a different color just so you know it's not the solution. I'm not a real solution. This is me showing a mistake. All right, so if I were to go and solve this side over here first, let's see what we come up with. So we use the exact same ratios that we found, 35.2 over the sine of 60 is equal to 20 over the sine of B equals 30 over the sine of C. Now I'm going to ignore that second piece of information on that list of how to solve these that told me to solve the one opposite the smaller side first. I'm going to go ahead and solve C. It's opposite the bigger side, but it doesn't matter. So let's see. I'm being facetious there. It does matter. That's why you want to always choose the one with the smaller side. So if we do our multiplication, we're kind of ignoring this. So 35.2 times the sine C is equal to 30 times the sine of 60. So that means the sine of C is going to equal 30 sine of 60 divided by 35.2, which is going to be approximately 30 sine of 60 divided by 35.2. That gives me 0.7381. Now, once again, I'm not knocking off any decimal places in the calculator. I'm just rounding to 4 decimal places for what I write down. So when I do second sine of that value, I get 47.56. All right, so we see here that if we solve for C first, we're going to get the wrong answer because C is 91 degrees. Here we get 48 degrees if we round to the nearest degree. And that's not only going to throw C off, but it's also going to throw off B, because when we find B to be 180 minus the sum of those two, 60 plus 48, we end up with B equaling 72. Now, one thing you'll notice when we do it this way, what we notice about every single one of our angles, well, they're all acute. And that has to do with the fact that we're misusing the law of sines. The law of sines will not identify an obtuse angle. So when we're supposed to identify C as 91 degrees, if we use the law of sines and did this one first, then using the law of sines, notice we don't get the correct answer. So be very careful about that. You always want to do the angle that's opposite the smaller of the two sides. All right, you guys work this one out, and they actually give you the one obtuse angle, so it's not that big a deal this time. But use your law of cosines first to find out what A is, and then after you've got A, use the law of sines to find out what angle B and angle C are. Or use the law of sines to find angle B, angle B, since it's opposite the smaller side, and then use subtraction to find angle C. Okay, I'm going to pause the video, and I want you guys to work it out. I'm going to pause, and then I'll come back and show you the answer. Now I'm going to show you the answer here in 3, 2, 1. All right, so here are the answers. Side A should be 13. Angle B would be 28 degrees, and angle C would be 32 degrees. And here's the work if you need to check your work. All right, now if you're given 3 sides of a triangle, in other words, you've got the side, side, side information given, then solving the triangles involves finding the 3 angles, not a mixture like we've had in the past. So we use the following procedure. First thing is use the law of cosines to find the angle opposite the longest side. Now the reason for that, again, is the whole obtuse angle thing. Remember, the law of sines will not find an obtuse angle. So we want to find the largest angle to find out if it's obtuse. And the law of cosines will find an obtuse angle. The law of sines will not. It'll give us the wrong answer. So whichever angle is opposite the longest side, you want to find it first. Once you find that angle, you can use the law of sines to find either of the other 2 remaining acute angles. They're both guaranteed to be acute because you found the largest angle in the first part. So the other 2 are guaranteed to be acute angles. And then you can find the third angle by subtracting the measures of the angles found in steps 1 and 2 from 180 degrees. Because all 3 angles of a triangle are going to add up to give you 180. So find the angle opposite the largest side first. It's the largest angle using the law of cosines. Then use the law of sines to find one of the other 2, and then find the third angle by just subtracting. All right, in actuality, here's the study tip thing, and it says the truth. You can use the law of cosines to find either of the remaining angles in step 2 instead of the law of sines. And I would choose the law of sines because it's simpler. It's just a ratio. Whereas the law of cosines is the big, ugly, nasty thing. So if we're looking here, let's go ahead and solve this. Let me go ahead and get this out of the way. Well, let's go ahead and solve it. Let's just work it out. So we've got to solve triangle ABC if side A is 6, side B is 9, and side C is 4. So B is the largest side, so we want to find angle B. So that means that what we're going to do is we're going to end up with B squared here, A squared plus C squared minus 2AC cosine of B. Now, what we're going to end up doing is moving everything else over to the other side and just solving for cosine B. So you can do that before you put anything in, and that's what I'm going to do. So I'm going to go ahead and move the A squared and the C squared over. So you're going to have B squared minus A squared minus C squared is equal to negative 2AC times the cosine of B. If I want to get cosine B all by itself, I'm going to divide both sides by negative 2AC. Now, you can go ahead I'm going to write the cosine B over on the left side instead of the right. And if you simplify this down, you can actually take this negative and go up here and distribute it through. And what you'll end up with is a squared plus c squared minus b squared all over 2ac. Now you can leave it with a negative on the bottom. That's perfectly okay, but that is just, I like that better. So when you plug everything in, you're going to end up with 6 squared, which is 36, plus c squared, which is 16, minus b squared, which is 81, and that's going to be divided by 2 times a times c, so 2 times 6 times 4, which is 24. So the cosine of b is going to end up being, when you put all that together, 36 plus 16 minus 81. It gives you negative 29 on the top. And on the bottom you're going to have, of course, 48. And then when you calculate that to find the decimal version, so negative 29 divided by 48 gives you negative 0.6042. All right, and to find angle B, you're just going to take the inverse cosine of both sides. Be careful here, we've been using inverse sine, and if you're not thinking about what you're doing, it's really easy to type the inverse sine in instead of the inverse cosine. But you'll get the wrong answer if you use inverse sine. So when we use the inverse cosine, we're going to get an angle of 127 degrees. We're rounding our angle measures to the nearest degree. So 127 degrees. All right, so at that point, we can go and we could actually use this again with either A or C and use the law of cosines and do it, but it's so much easier to do it with the law of sines. So let's go ahead and set up just the first two ratios of the law of sines. So we're going to have A, which is 6, over the sine of angle A is equal to B, which is 9, over the cosine of the angle we just found, 127. Do our cross multiplication, and we're going to have the angle A, so let's go ahead and find sine A. When we do our cross multiplication, we're going to end up with 6 times the cosine of 127 divided by 9. Sorry, I did cosine. That's actually not cosine. Don't forget. See what happens? It's easy to make that little mistake, and when you're swapping back and forth, it's real easy to do it. So 6 times the sine of 127 divided by 9, and I get 0.5324. All right, and that's the decimal just written to 4 decimal places, but I'm using all the decimal places in my calculator, and now I'm going to find what A is. So here's where I'm going to take the inverse sine of that decimal, and I'm going to get 32.169, or 32 degrees. All right, so now once I know 32, I know 2 of the 3 angles in this triangle. If I know 2 of the 3 angles, it's easy to find the last one. I just take 180 and I subtract the 2 angles that I know. 127 plus 32. Well, 127 plus 32 is going to give you 159. 159 minus 180 is going to give you 21. All right, of course, and that is angle C, the one angle we don't know. So now, and through our work here, we've actually found that A is 32, degrees. B is our 127 degrees, and angle C has a measure of 21 degrees. So in this case, we were given the three sides, and we've solved it when we found all the angles. All right, so here's another example. I want you guys to try this, and I'm going to work it out and show you the work for it, but I want you guys to pause the video, give it a try, and see if you can come up with the correct answers. Now I'm going to pause, I'm going to show you the answers, and 3, 2, 1. All right, so here's the answer to this problem. You're going to end up getting angle A is 52 degrees, angle B, which is the first one you're going to solve for, is 98 degrees because it's opposite the largest side, of course, and then C is going to equal 30. So solve for B first because it's opposite the largest side. That's going to be using the law of cosines because the cosine will give you an obtuse angle like it has in the last two. And the law of sines will not give you an obtuse angle. That way you get the biggest angle out of the way. Whether or not it's obtuse, it doesn't matter because cosine is going to actually show you whether or not it is. Law of sines will not. And then once you find that, you can use law of sines, or you could use the law of cosines on this second step. I like the law of sines. It's just easier once you've got the obtuse angle out of the way and you've got a complete ratio. And then just use subtraction to find the third angle C. You could have easily gone up here and after this first part used and solved for C, and you would get the exact same thing that you should get here within a couple of tenths of a degree. All right, so applications you can also use the law of cosines with, much the same way you did the law of sines. Two airplanes leave an airport at the same time on different runways. One flies on a bearing of north 66 degrees west at 325 miles per hour. The other airplane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart will the airplanes be after 2 hours? All right, so if we go 325 miles per hour for 2 hours, that's going to be 650. If we go 300 miles per hour for 2 hours, we're going to be 600 degrees in that direction. Now remember the way you set these directions up. Your first one tells you where you start. So we're starting at north and we're going 66 degrees to the west. So that means we're going to start here and we're going to go 66 degrees in this direction. So this is 66 degrees. So if we want that in standard position, well, never mind. Let's get back to what we're doing here. Sorry, west. I did east. So north, 66 degrees west. So that's this direction here. And that's this angle, 66 degrees. So from north, I'm going 66 degrees. What's this actual angle right here? Well, we can find it since we're going from the exact same place down here. If this is 66, what's this angle? Well, if this is 66 and these two angles add to give you 180 degrees, that means this one's going to be 24 degrees. All right, and then in the same way, we need to figure out this one. Well, it is south, start off with south, 26 degrees to the west. So we're going to go off in this direction, and this is 28 degrees. Well, if this part right here is 28 degrees, what's this part right here? Well, that part right there is going to have to be whatever's going to add to 28 to give 90, which is going to be 62. So now, what is this big angle right here going from here to there? Because that's going to be what? It's going to be this angle right here on our picture. Well, it's just 62 plus 24. And 62 plus 24 is going to give us 6 and 86. So that angle right there is going to be 86 degrees. All right, so now which one of our operations do we have? Well, we have side angle side. We don't know what B is. We're actually going to try to find B. So we have side angle side, and that means we're going to do what? We're going to use the law of cosines to find what B is. So B squared is going to equal A squared plus B squared minus 2, sorry, that's C, AC cosine of angle B. So everything over here we've got in our picture so we can plug in. Doesn't matter what you call A, but since it's already drawn here, we know we're going to call this little a, this little c, that big B. All right, so when we put all that in, we're going to end up with 650 quantity squared plus 600 squared minus 2 times 650 times 600 times the cosine of 86. And that still equals B squared. So we would punch all that in our calculator to find out what B squared is. Right, and I get that B squared is 728,089. 0.9505. All right, and then I have to take the square root of that to actually find out what B is. And that gives me 853. 0.28, so we'll say 0.3, and my distances are in miles. So how far apart are the airplanes? Well, all we've got to do is find that B, and it's 853.3 miles. Now, notice we don't have to find angle C and angle A. All they're looking for is that. So you have to be able to apply it and figure out what they want you to find. All right, you guys try this one. See what you can come up with. Two airplanes leave an airport at the same time on different runways. One flies directly north. You guys got the easy one. At 400 miles per hour. The other plane flies on a bearing of north 75 degrees east. At 350 miles per hour. How far apart will the airplanes be after 2 hours? Well, if this goes 400 miles per hour for 2 hours, it's going to be 800 here. And if this one flies 350 miles per hour for 2 hours, it's going to be 750 here. And then all you're looking for is the distance from here to there. So do your work, see if you can get the correct answer, and then you can pause the video while you work and then come back and check your answer. And I'm going to show you the answer in 3, 2. Okay, and here's the answer. So when you plug it in, it doesn't matter how you label your triangle here with your A, B's, and C's, as long as you remember that your side A is opposite your angle A, your side B is opposite your angle B, and your side C is opposite whatever angle you're going to call C. And then just make sure that you set up and use the correct one to solve for the correct side, and the distance between these two is going to be 944.4 miles. Remember, you're going to work all that out, but remember that is a squared, not a, and you're looking for a. So once you get a squared, you got to take the square root to get the actual answer itself. All right, now the next thing we're going to talk about is Heron's formula, and it's approximately 2,000 years old. Ago, the Greek mathematician Heron of Alexandria derived the formula for the area of a triangle in terms of the length of its sides. Now, a more modern derivation uses the law of cosines, and you can look at it if you want to, but I don't think you would. But you do need to know how to use Heron's formula, and the area of a triangle with sides A, B, and C is just the area is equal to the square root of S times S minus A times S minus B times S minus C, and then take the square root of that, where S is 1/2 its perimeter. In other words, 1/2 of A plus B plus C. Now, if you know this equation, it's real easy to use, and you're going to have to know the equation. I'm not going to give it to you. And you're also going to have to know what S is. So remember, S is just 1/2 of the perimeter, 1/2 the distance around the triangle, and then the area is just the square root of that distance times that distance minus the first side times that distance minus the second side times that distance minus the third side. All right, so let's do one of these. Okay, find the area of the triangle with A equals 12 yards, B equals 16 yards, and C equals 24 yards. All right, so the first thing we want to do is we want to find what S is. And S is 1/2 12 plus 16 plus 24. Well, 12 plus 16 gives me 28. 28 plus 24 is going to give me 52, and 1/2 of 52 is going to give me 26. Now, in case you are thinking, or you want a shorter, you don't like those big numbers, just take 1/2 of 12, 1/2 of 16, and 1/2 of 24. All you're doing there is you're distributing the 1/2 through and then adding them, but you're going to get the same thing. You're going to get 6 plus 8 plus 12. Well, there's 26. There you go. So just another way to do it. So now, once you get S, you know that the area is just the square root of 26 times 26 minus 12 times 26 minus 16 times 26 minus 24. That is the application of Heron's formula with this triangle right here. So 26, of course, is 26. 26 minus 12 is going to be 14. 26 minus 16 is going to be 10. And 26 minus 24 is going to be 2. So when we multiply all that out, we got 26 times 14 times 10 times 2 gives you 7,280. So that means the area is the square root of that, which is going to give you 85.3. But since we're rounding to the nearest square yard, it's just going to give you 85 square yards. See? Easy breezy. All right, you guys try this one. Just like we have in the past, I'm going to pause. I'm going to show you the work, and I'm going to give you an opportunity to pause the video, work it out for yourself, and then check your work. I'm going to show you the answers, or the answer, in 3, 2, 1. All right, so here's the solution. When we find S, we're going to have 1/2 of 6 plus 16 plus 18. And 6 plus 16 gives you 22. 22 plus the 8 would give you 30. plus the 10 with the 18 would give you 40, and 1/2 of 40 gives you 20. All right, when we get into the area formula, we've got the square root of s times s minus a times s minus b times s minus c, which gives us 20 times 20 minus 6 times 20 minus 16 times 20 minus 18, the three sides of the triangle, which simplifies down to 20 times 14 times 4 times 2, which gives us 2240. When we multiply that out, and the square root of 2240 gives me 47, and that is in square meters. All right, that's all for 6-2.